Hi everyone, I'm Han from UCL. Today I'm going to talk about how listeners adapt to noise-vocoded speech under different types of divided attention. So we know that humans can improve their perception of speech over time, like in a very short 30 trials of exposure. Some previous studies suggested attention might play a role in perception learning. However, our previous findings showed that speech perception learning persisted under different levels of divided attention, even when listeners were asked to perform hard concurrent task while understanding the sentences. So in the current study, we further explore whether perception learning remains robust when a concurrent task taps into different aspects of speech processing. If perception learning is indeed robust, the improvement in performance over time should be equally robust under a domain general visual task or a domain specific phonological or lexical task. Whereas if learning gets worse under a domain-specific task than a domain general task, learning should be considered dependent on a domain-specific process. So we got 192 people on prolific assigned to different groups. One group heard a bunch of noise-vocoded speech and repeated them back. Noise vocoding essentially removes some spectral information, thus a speech will sound like someone whispering very harshly. All other groups performed a dual task where they heard the sentence while seeing a visual word flashing briefly on the screen. In the visual spatial group, listeners decided whether a word was 45 degrees or not. Listeners in the phonological group decided whether the word contained two syllables or not. And finally, listeners who did the lexical task decided whether the word was a man-made object or not. We used generalized linear mixed effect models to fit the data. And we first found comparable accuracy for performing all three secondary tasks. We also found a similar trend of adaptation under all task conditions. However, speech task under the phonological condition showed significantly higher performance than all other task conditions. Listeners also had greater accuracy performing the speech task when they made a correct response to the secondary task than when they made a incorrect response. These results show that perception learning is resilient to different types of divided attention, that is, domain general or domain specific to speech processing. The noticeably enhanced speech perception in phonological condition might be due to the suppression of distracting process by the secondary task, which made the speech task processing more efficient. Finally, listeners might be more engaged in speech task processing when they also made a correct response to the secondary task. Thanks for your attention.